This video is going to deal with the composition of two functions. So what we're going to look at now is when given certain functions, how can we compose those functions or actually combine those functions? And we've worked with this before, but we'll go ahead and review it. So what I've given is a simple example here where we've got two functions. We have f of x equals 2x minus 1, and we have g of x equals 2x squared minus 3. A function, remember, is a set of values where you have a set of inputs which creates a set of outputs, and they all follow the same behavior or the same pattern. And that's what we get, that's why we call it a function. This expression is a function of the x, or your y value is always a function of your x value. And that's why we have the x in the parentheses here. This is not a multiplication. This doesn't mean f times x. I know we normally associate parentheses with multiplication, but that's not what we have here. So this means a function of x. So what that means is x is going to be our input value. So let's look at this example right here, number 1. I have f of g of negative 3, and that's how it's set. That's how you write it. Okay, so you write it like this: f of g of negative 3. So if you're wondering how to say it properly, that's how we say it. Function of g, function of negative 3. So it's functions of each other. So what we do is we work inside out. You're always going to work inside out in your functions. So whatever's inside, we're going to work our way out. So the first example that we have is f of g of negative 3. So working inside out, that means g of negative 3 is going to be my first operation. So what I'm going to do is negative 3 is my first input, and I'm going to input that into the function g of x. So that's this function here. So since g of x equals 2x squared minus 3, what I'm going to end up doing is for g of negative 3, I'm going to plug in a negative 3, and you always put parentheses around your substitutions. I'm going to input a negative 3 in where I saw an x. Everywhere you have an x, because the x represents your input. So anywhere you see an x, you're going to input your value. I'm inputting a negative 3, so I'm going to put it in for x. 3 squared is 9. 2 times 9 is 18. So we have 18 minus 3, which gives us 15. So basically what this would mean on the graph is for g of x, if my x coordinate was negative 3, my y coordinate would be 15. That's just a little FYI, so you know what it is you're doing, what the operation is. This is your input, this is your output. So the way these compositions work is it's kind of like a chain. So now, once I've established g of negative 3, which is 15, that becomes my new input for f. So now I'm going to input the f. I'm going to do the same thing. And since it's f of g of negative 3, well, what's g of negative 3? Well, it was 15, so I'm going to find f of 15. So I'm going to go to my f of x, which is 2x minus 1, and my input, 15, is going to go wherever I see an x. So I'm going to have 2. And then for the x term, I'm going to input 15, because that was my input value, minus 1. All I've done is input. So 2 times 15 is 30, minus 1 is 29. So your final answer, f of g of negative 3, is 29. So let's move on to the next one. Let's just look at simple g of f of x. If I just do g of f of x, looking at these two, what I'm going to see is that there is no numeric value here. What if it's just a variable? Well, we start off again by looking at our first one. We work inside out, and this is pronounced g of f of x. So we're going to look at the function of x. Well, if it's up here we had a negative 3. Here we just have an x. So if your input is just x, we already know what f of x equals. It's 2x minus 1, right? So f of x is equal to 2x minus 1. There's nothing to plug in. So what I'm going to do next is now, since I already know f of x, which is 2x minus 1, I'm going to plug that into g. So my input was x. I got 2x minus 1, and I'm going to input that into my g. So I've got 2, and then you do your input. So for here, I've got x cubed. So that's my input cubed. That's how you read it. Your input, squared. Your input squared. So I'm going to plug in 2x minus 1, and I'm going to square it because that's my input. And that's going to end up giving me 2x squared minus 1 squared minus 3. So now I just have to expand this, and I have to combine. I have to simplify it. So let's do order of operations. Let's do the 2x minus 1 first. I've got 2x minus 1 times 2x minus 1. Now you can do your distribution, this one times this one and this one, and this one times this one and this one. And then you'll end up with, just to save some time, you'll end up with 4x squared minus 4x plus 1. But remember, what do we still have attached to that? The 2 and minus 3. So my next step is going to be to distribute this 2 throughout. So I've got 2 times 4x squared, which is 8x squared. And I have 2 times negative 4x, which is negative 8x. And 2 times 1, which is 2. And then I still have that minus 3 there on the end. Now I'm ready to bring the 3 in. So I have 8x squared minus 8x. And then 2 minus 3 is negative 1, and that is your answer. So again, there was your answer to the first one. So that's how you do a regular composition. Now moving on, let's say we have it written in this format. Number 3. That is still pronounced f of g of 2. That's the same thing as writing f of g of 2. That's just a different way of writing it. So we're going to go into our function g of x, and we're going to find g of 2. Because remember, we go inside out. So 2 is my input. Remember, g is 2x squared minus 3. So I have 2. And my input is going to go in for x, input for x. And my input is 2. So 2 times 2 squared minus 3. So g of 2 is going to give me 8 minus 3, which is 5. So g of 2 is 5. So what that tells me now is I can go into f, and my input for f is going to be that 5, my output for g. So f of 5, I'm going to look at f of x, it's 2x minus 1. So I'm going to have 2, my output, which is 5, 2x minus 1. So that gives me 10 minus 1, which is 9. And that is your final answer. Okay. Now what if I did g of f of x? Whoops, sorry, g of f. We've already had g of f of x. Sorry, that's a repeat. So let's move down here to number 5. Number 5, we have f of g of 4x squared. So just to kind of get this in the same frame, remember, f of x equals 2x minus 1, and g of x is equal to 2x squared minus 3. So there's your two functions. So let's work inside out. Once again, g is inside, so we work inside out. G goes first. So I'm going to take g of 4x squared. So that means anywhere in g where I see an input, which is my x, I'm going to insert 4x squared. Well, I have input squared, so it's going to be input squared. Look at each of these as an input. That's your input. That's your input. See, I have x squared here, so I've got 4x squared here, minus 3. 4x squared to the second power. Remember, you square everything inside. So that becomes 16. Power raised to a power, you multiply the power, 16x to the 4th, minus 3. And then I can now distribute the 2. 2 times 16 is 32. Apologize for that. 32, x to the 4th minus 3. That is our first one. That is our g of 4x squared. But we're not done, because now we have to take this output, and that becomes our new input for f. So I've got f of 32 x to the 4th minus 3. And I'm going to plug, yes, this whole thing in for my input. So I have 2, and then my input, which is going to be 32 x to the 4th minus 3 minus 1. Move this over a little bit. And now I'm going to distribute. I'm going to follow the laws of exponents. So I'm going to take I'm going to take 2 and multiply it by 32x to the 4th, and I've got 64x to the 4th, and then I've got 2 times negative 3, which is negative 6, and then I've got minus 1. So that minus 1 is still hanging out. So I've got to look and see if I can actually combine like terms here, and I can. So I've got 64x squared, which does not have any like terms, but then I've got minus 6 and minus 1, which is minus 7. And you're done. So that's f of g of 4x squared. And we are going to do a couple more examples. We're going to do compositions with more than 2 functions, but that'll be in the next video.